Right, we should be back. Okay, so that was a bit of a bugger. Yeah, I had to plug in my. So I tried to restart the PC, then it would boot up with the USB hub being plugged directly into the motherboard. So then I had to unplug everything from the USB hub and plug it all in individually. And the reason why I have it on this hub is so I can switch it between my work PC and my home PC without having to move much. But I think this part of it's been just taking a beating over all that time. So I think that's where we're at on that one. So I've got to order a new one, I think. Christmas time, a USB hub. So yeah, where was we? We were talking about OOP before we got completely destroyed by things. But yeah, OOP. Someone was talking about. Yeah, Lech was talking about. I think OOP constrains the mental model a lot. It kills creativity and experimentation. Yep, agreed. But maybe if you're not smart enough to come up with solutions yourself, a guideline is better than nothing. Although you're not getting smarter, you're yeah. See, that's my problem with it. Is that you're getting indoctrinated into the OOP model. You then will fail to see outside of it, and then whenever someone teaches you how, whenever someone else tries to teach you about programming in a better way, your mind is already coming from it from an OOP perspective. So I think it's quite toxic, actually. I think you can learn OOP, but I think you should learn how to do it procedurally first. Because, again, procedural programming is not structured, it's unstructured. It's not telling you how to solve a problem, it's just saying we have abstractions like functions and structures. Do what you want with it. OOP comes along and goes, they're all objects, mate. Methods, inheritance, encapsulation. So that's OOP. Toxic. Yeah, hopefully that's the source of the blue screens. We'll find out, hopefully. If it doesn't blue screen the rest of the time, we can assume that's it. Why do you use Windows for dev? No. I installed a new graphics card, and what happened because my previous graphics card was crashing my computer whenever I had a GPU crash, which is like ugh. So I got a new one eventually, finally, installed it on Linux. It allowed me to remove the driver and but not reinstall it. And I had to do that because apparently it wouldn't pick up the same AMD driver which was already installed. I have no idea. So the people suggesting uninstall it, reinstall it. Hopefully that works. So now I'm just gonna reinstall my whole system because I've hosed it. So yeah, I I really would not like to rush installing it because I've got data on there I need to fish off of it. So I'm hoping to get around to it soon. Today's dominant model in gaming is ECS. I think everyone ECS is yeah, that is true. But also they are blindly ECS, um, without thinking about why they want it or um, and blindly be like, oh, it's performant now, you know. Um, and the code just gets really complicated too. So your code becomes more complex, which might not be worth the trade-off. We wrote an ECS inspired system, but I didn't call it an ECS. I got an entity code generator where I'd taken an entity file and then code generate the rest of it. And the entity file just literally defines structures with a bunch of components as well, actually. Yeah, it's in the logic one. Yeah, you got a layout file, right? You put your properties in there, put your archetypes, and boom, code generates. It's just all memory efficient and in grids and things, but I did it like this because I was going to be simulating a whole world for this game. So hopefully we still stick to that. If we do not stick to simulating a whole world, then this will probably get changed dramatically, and we might get rid of the whole ECS thing. If we do not stick with it. But the reason why it's got this is because I wanted to simulate a whole world. So having things organized into cells and move around these pools based on a grid, and be in this sort of structure of arrays format is beneficial for that. Right. So it's getting kind of late, and I wanted to have this working. I cannot figure this out for the life of me today. We tried. We tried. But it's time to admit defeat. We were so close. We were so close. Maybe, you know what? I'm smarter now. I've learned things. So maybe all we need to do is use a little bit of Fresnel. I used NeoVim/Vim for a good while. I used Vim for a while, then I switched to NeoVim to see what the fad was about. Then I switched to Helix, which is another Vim inspired editor, but for the modern day. Yeah, I do kind of like Helix. It's got a few little issues though, and I haven't really fully mastered my Helix thing. But yeah, when I go back to Linux, I might rethink about my editors again. I don't know. See. Right, that's the MSAA one. This is the gotcha. So here's what we're gonna do. Gonna be good. So imagine. Just imagine. If we could know what is an edge and what is not an edge. Well, it's quite simple, right? You get, for a sphere at least, you can get the surface normal, and you can get the ray direction, and do the dot product. RD dot N. So the dot product between these two vectors, if they're perpendicular, there'll be 1. Right, perpendicular says like a right angle. If they're pointing the same way, they're going to be... Wait, sorry. Perpendicular, there'll be 0. Pointing the same way, there'll be 1. Pointing the opposite way around, there'll be -1. So what we're looking at doing is doing a max. We don't care about the 0, but a negative value, right? We want to completely get rid of it. Wait a minute, do you want to do max? Because max will make it, yeah. We'll never get a max. Yeah, and then we negate it. One take. So now it means 1 is perpendicular and 0 is pointing the same way. Wait. Yeah, that's the ray direction. So you got to negate that. So this is basically like what the Fresnel is like. So you use Fresnel. So let's color it. I could probably get the Fresnel one. Let's say if we poke this into the color. So we'll be like, let's make the color this instead. And let's take, so instead of doing a lovely PBR shading, let's just color it based on how perpendicular the normal is. What? Value thing. Oh, the return value. Right. Gotcha. Yeah, I got rid of the RTAA one. Oh, yeah, we don't have this anymore. Yeah, I nuked it. I was like, we spent too long trying to do it that way, but we've learnt stuff. Let's just try it with the Fresnel now. I'm admitting defeat. Right, so as you can tell, the closer it gets towards the edge, the more white it is. So we want to somehow scale it back. See, as we get closer, it's more and more pointing in a direction where it's making it look white. But yeah, we can have a bit of a play. So there's a thing called Fresnel, which we use in PBR, but it's spelt Fresnel, but the person's French, so apparently pronounce it Fresnel. So there's a Schlick implementation of it, and it basically does that. Has a bit of roughness in there as well. So me pass in n dot v or whatever, the v normal. So one take pow. So yeah, I reckon we won't use Fresnel, but it's inspired by that. So why does it look the way it does? These should be normalized. So let's see what this value is. Let's print it out. So yeah, I made my own C to SPIR-V compiler, so I can share code between CPU and GPU. Because I think that is the future, and we've been denied that future for, you know, since the existence of shader programming, really. And I would like to live that future today, so that's what I've done. And also, I've added stuff like printing as a first-class feature to the for crying out loud, I forgot to put a new line in there. And I didn't put an if statement to say. Is mouse at? So it only prints out for one pixel, not all of them. Yeah, man. Yeah, too many pixels, all the pixels. Right, there we go, that worked. Right, so just hover over the pixel, see what we get. Right, so it's smooth, right, from 0 all the way to about 1. Oh, 0.5? About 1, alright. Yeah, it's up here. Now the beauty of it is, right, so for some reason this is all white here, I don't know why. I don't know why it's looking so damn white. There's a blend. Is it because it goes from linear to sRGB or something like that? It might be that. Anyway, the value we're getting is good. So what we need to be able to do is figure out how do we say that this is kind of close to 1, which is close enough that we need to apply some alpha. So this alpha here, right? Well, we need it. The thing is we actually need this normal to be calculated up here. So upon a hit, adds a bit of complication here. Not a fan about it. But here we go. I mean, your recalculate again is not happy with this. You're not happy with this. You gotta do it twice, have you? Right, we can try and optimize it later. So you get your this guy. Now you need some kind of like what is deemed close, right? So if we take this pixel size at near clip plane, so we get Milton open again. This is the size of a pixel at this where the texture is, right? So the camera starts here and the texture is kind of placed here. This is the size of a pixel here. So what we kind of want to do is either bring this back into the near clip space or bring this out to where this is and then use that as some kind of metric. So I think if we say pixel size at depth, that would be this multiplied by t near. We're just scaling it out. Then, so we're just scaling this pixel up so it becomes something like that. A bit bigger, yeah? At that depth. Then, we can use that as some metric where we probably multiply it by some magical number. We might have to scale it down or scale it up. But the idea is we might have to times it by 0.01 or something. I don't know. Might be a bit too big, I think. That's why I'm doing it. But we could leave it to be big just to see it working. Then all we're trying to say is if we're trying to say the alpha, alpha equal lerp between whatever the current alpha is and 0, is that right? Now I think you want to work out the new alpha and multiply. So you want to work out the AA alpha. AA alpha between 0 and 1. Oh, right. So there's no lerping anymore then. So you take that. Would I have to 1 minus it again? 1 minus, which means I could probably undo that and simplify it and make it less readable. Pixel size at depth. Right. And then take that pixel size at depth. What am I doing? One take. And if that's and divide it by this and then clamp it. Yeah, divide it by that and then clamp it. So the closer it is to this or the further it is past it, it will be 1 plus. And then if not, it'd be 0. So if we clamp this valley between 0 and 1, we'll then have this AA alpha. Then we can join the two together. The current alpha with the alpha and voila. So let's take a look at what we get in AA alpha as well as another value just to see. Redirection times hit depth. Ooh, hit depth is T near. Nice. Oh. Ooh. Right, so now we should begin pixels fading out towards the edge, but they're going to get super faded out. Probably, because I need to multiply it. So, let's see how it goes. Right, we're not getting anything like that. I can't see it. I can't see it being transparent anywhere. We can even see the jagged edges still. Right, still an alpha of 1. This ain't good. Clearly, I did maths wrong, which is expected. What is that? Right, it's above 1. Right. And then you scale it out. What's my pixel size? And a clip. What is that? Is it a 0 point something value? Zero 0.01. Right, so it actually shrinks the value down already. Right. Got to be careful with. So it becomes 1. If it's not n dot, This is just silly. Right. So the perpendicular is the 0. Let's take away this 1 point. Okay, there we go. So as they get closer to the edge, it gets closer to 0. Yeah. It gets closer to 0. So if I did... Would that do it? No, then you might as well just do... What would you get for that? Welcome, Kevlar. How's it going? Good evening. What is reverse ellipsoid normal? So it just gets the normal of the ellipsoid given. So you pass in the hip position. And then it will... so this is taken from IQ's blog again. You square the radius. Yeah, divide that down. So I guess you... Huh. It's, you put it into the norm... Right. You put it down into a sphere, kind of, and then you normalize it. I think. Yeah, something like that. It's just the surface normal. Right. Cool. So we're getting pixel dust on the end. So why are we getting pixel dust? That's the opposite of what we want. So that's all transparent. Um, so 0 is perpendicular. No, sorry. Yeah, 0 is perpendicular. 1 of it's pointing the same way. Um, so my alpha needs to be... So the closer it is to 0, the more you want it to fade out. Do we need a lerp here then? We probably need a lerp. Right, we need some kind of value to be like this is to know where the starting would we say we need an inverse lerp? Maybe. I believe it's in the unit sphere space, yeah. The normal is the ellipsoid, not the same as the sphere. Yep. Hmm. Yeah, I think I calculated it later, right? There's a um there's an ellipsoid one. So it's the same as that, but so position is right, but I didn't see you change the function. RO. Right, this might be wrong then. RO plus T times that, but RO is... We might have changed the function in here and I've copied it and got confused or whatever. Let me just check quick. Right, so he does it in the local space. Right, then he does that in the local space. Right. So this has to be in the local space of the object, and I think I've done it in world space. This could actually be wrong. Which means this is what needs to be passed in. That, the hit. Crap. Thank you for bringing that up, Albert. I think you've found a bug. The normal might be wrong. Yeah. It's just that. What a bugger, eh? Yep. Right, so that's in local space, then that gets transformed into world space. But you need to apply the scaling right on the way out as well. It's already... All I can do is apply rotation and positional things from there. It's already scaled. In that case, get the world space one. It'll be multiply unit. Is it just rotation and position? So that'll be world from local. And passing in that vector there. That will be the corrected thing. The issue is I don't have these guys anymore. So I might have to encode the normal in a temporary... This will eat away at the registers. Ain't good. But we'll put it in there anyway. For now. Um, start this on that. Right. Okay. So already a closest hit. Not sure why I named it that, but anyway. We calculate that again, and this can get pulled out. But I guess it could be done in world space as well. No, because it has rotation. You got to do that. Pull it out. Rightio, let's give that a go. See how it looks. But yeah. So this let's just comment out that for a sec. That normal should look better. Oh shit, what did I do here? That didn't work. Oh, the position, wasn't it? It's just the unit. It's a vector. Nope. Well, I kind of looked alright before though, but oh, from the center of the object, but that's 0. Take away 0. Yeah. No, I do need to add ray origin. Ray origin is not 0, isn't it? That's why. Right, there we go. I don't know if it looks any different, to be honest. Hard to tell. I guess we can tell when we stretch the ball out. So we'll stretch it along the X. That's looking really stretched now. And it looks a bit incorrect. The other one looked more realistic. Yeah, let's undo that. I don't know what was going on. I think the other one I had was actually correct. I don't know. Right, there we go. We're back in business. So the closer this is to 0, the closer it is to the edge of the screen. But you need to somehow say there's a threshold that we could probably use as pixel size at depth. This grows as it gets further away from the camera, meaning the more leeway you have. So this divided by that should get you a value from 0 to 1. You can clamp it. And going past 1 would, yeah, you want it to be clamped. But yeah, that should be it. Alright, see what we get. That should get us a nice soft border. Right, I can't see that. Have a look. Right. So what we're seeing is there's already bigger. So we're going to need at least times it by 10, I think. This is where the magic happens, basically. I think we need to multiply this thing by 10. So the magic scaling number, let's just say 10. Then we just got to find the perfect number, basically. Yeah, exactly. 10 times better. There we go. Now it's got a beautiful soft edge. But it's a bit too soft. But I could take a screenshot. So here's a screenshot we can view in the screenshot viewer. Zoom in, enhance. You'll notice here this is all sort of transparent and blends. But it's... yeah, it's not what we want. No. But it's close. So it looks like it went a bit overboard, so maybe we can times it by 4. You know what, maybe the perfect number is pi. That would be amazing. It's got to be pi. Yeah, pi or 4 are the perfect numbers. Right, we're getting a bit of an edge. It's a bit soft. But it could be softer. It's alright. Yeah, the golden ratio is a bit too small. But the golden ratio is like half pi, right? So it all comes back to pi. So times by 4. I think 4 is going to be the good number, unfortunately. Oh. Too much talking today. Right, here we go. I think that's it. So we've got to change the screen resolution, check things out, and move the distance away. Make sure it works. Yeah, 4's probably a bit better. Hard to tell. But I'm not noticing the edges as much. Up there by the white I am, but that's a different problem. So if we just move it back. I'm not seeing it behave too badly, except for where those white pixels were, which we know is a problem, and how to solve that, I think. So we move this back. Do we still get... F7? Right, we've still got a nice anti-alias edge. I think it's a bit bigger, not gonna lie. But I don't think it is actually, because we're still seeing the I think that's the Fresnel and the reflection. I think. Or it's just the reflection in the... Yeah, so I think that's quite good. Let's keep going back. And then we'll try going close. And then I think that's that shader. We'll test out performance as well. See how it compares to the SSAA, which is really expensive. Takes me ages to move in this game. But yeah, let's just stick it there for a bit. Screenshot. Alright, it. I'm happy with that. So yeah, let's get it in a bit closer this time. Let's see a nice close-up sphere, make sure it's alright. But I think that view distance is working well. So we're gonna get right close to it, like we're good friends, giving it a nice hug. Take a screenshot. Zoom in. Yeah, I'm seeing some anti-aliasing happening at least. It does look a bit sharp though, when it's a bit close. Which is kind of concerning a bit. So maybe 4 isn't the magic number. Maybe it's 5. A little bit more soft. Get in there real close. I can't see too much, although it's hard to tell because the ground. Oh, yeah, we're getting some alpha there. That's good. Maybe what we're seeing here, actually, in all fairness, is the bright side of things. No. Alright, but it is blended better. Maybe we can up it a bit more, but that's alright. So. It's pretty cool. Should we check a little bit about performance? So we did something like put this back and we rendered 2 ellipsoids, and we went right up close to one of them, and when it was the widest, it was about 10 milliseconds on SSAA, and it was 5 milliseconds on MSAA times 4, both of them times 4. So this doesn't do an upscaled render at all, so we should at least expect to see a massive difference. But it's not as good anti-aliasing, right? The others are technically better quality. But the other ones still fail at the top here like this one does. This is a problem to do with bright lights that we'll solve later. So we're all in all about 1 millisecond there, right? So that's 10 times quicker than SSAA and 5 times quicker than MSAA times 4. So those ones are rendering at 4 times the resolution in different ways. But yeah, we're getting quite a lot of banding up close here. It's probably to do with the render not being complete. Look at that some other time. Yeah, let's get rid of the jaggeds. Yeah, jaggies. Yeah, so now it looks nice. Or nicer. There's still some banding happening here, but yeah. So yeah, and that normal looks alright as well, doesn't it? Yeah. I think the banding might come from... Hard to tell. Might be the cube map. Yeah, it's probably the cube map. But yeah. Completed it, mate. Looks good, didn't it? Yeah, so that's the one we'll use by default. We'll have it on. It probably has no impact on performance, basically. Very small impact on performance. We probably have ways of turning it off, though, actually. But we'll default to RTAA probably being on. Yeah. So what's quite funny is this was the first implementation that I did in the past. And we've just implemented other two, and this one is probably the better one anyway. But it's good to offer the other ones anyway, because people like a bit of choice. But yeah. Oh, that was long. So next stream, what we're doing. We want to try and render as many of these as possible. So we're going to tile bin these into screen tiles, and we'll have basically multiple instances. Wait, we're trying to do multiple model instances, and taking those ellipsoids and putting them into screen space and binning them into screen tiles and rendering them really quick. That's the plan. But yeah, we can hyper optimize these shaders later. But we've already tried to optimize them, but we can hyper optimize them later. It's not what I'm fussed about. Yeah, we want to make it scale to a ton of ellipsoids now, so that's the plan. Cool. Right, I'm gonna go and pass out in bed. The next stream is Sunday, about 5 hours ago. Stream's a bit late today, unfortunately, but we got the job done. Right. Yeah, thank you all for coming by, guys. I hope you have a good start to your weekend, and hopefully see you guys very soon. My voice is dying right now. This is a good tab, but I can't see what is Linux. There we go. Rightio. Right, catch you later, guys. Thank you so much. See you all very soon, and bye-bye. Much love.